Hey, this is Kevin from kevinsguides.com, and in this video we're going to learn about PGP, encryption, and Cleopatra. So this is one of the more popular articles on my website, and I decided to finally make a video for it. What you will learn more specifically in this video is what PGP is and the basics of how it works, how to generate key pairs using Cleopatra, how to sign, encrypt, and decrypt messages, do the same thing with files, and some basic safety practices. This guide is available in writing at my website, kevinsguides.com. I will put a link in the description if you want to check that out. If you got stuck along the way, feel free to go there, post comments there, get help there. All right, let's begin. So what is PGP? Well, PGP stands for Pretty Good Privacy. It was an application for encrypting and decoding messages, first released in 1991, mostly used in email. So basically, it's a way to encrypt and decrypt things. OpenPGP is a non-proprietary version based on the original PGP. And when most people refer to PGP now, they're talking about OpenPGP. I think the last version of the original PGP was released in like 2015 or something at this point, and the standard's still widely used today. And on OpenPGP's website, they claim it is I believe, like the #1 email encryption system to this day. Common use cases for PGP or OpenPGP: to encrypt information like private notes or journals, for encrypted communication in general, like if you want to send a private email to a peer or a coworker, to protect sensitive or classified information. It's also a popular communication method on the dark web, used to log into services, submit orders, look over customer information, things like that, for people buying and selling things they shouldn't be over the internet. It can also be used for file encryption, verification, or digital signing of files and messages. And finally, you might also use it to access certain applications. How does PGP work? Well, PGP is key-based. So there are these things called keys, which are kind of like randomized sequences of characters. They don't mean anything inherently by themselves, but we use that key to encrypt and decrypt this information. Now, a bit more specifically, every key is part of a key pair. So whenever we generate keys, we're always generating two keys. We want a private key and a public key. Every private key has a corresponding public key, and we can generate as many key pairs as we want if we need them for different applications. Now let's talk about the differences between a private key and a public key. So the private key is the key used to verify your identity or to sign encrypted communication. So the receiver has additional verification that the message came from you. And it's also used to decrypt messages sent to you by other people, and those other people should have a copy of your public key. Only you should have your private key. Don't share your private key with anyone. That defeats the purpose. If you lose your private key, it will be practically impossible to decrypt the information. So don't lose your key unless you intentionally want all that information to be inaccessible. And you can password protect your private key and create copies of it for backup purposes. And then the other side of this coin, we have the public key. The public key corresponds to your private key, but it is different from your private key. It's distributed to the people and applications that you want to receive encrypted communications from. So people can encrypt messages or files to you specifically with the public key that you give them. So this is a one-way transaction. Once a message is encrypted with a public key, only the holder of the private key can then decrypt that communication. You can't go backwards with just the public key. So it's safe to give your public key to people or even post it publicly depending on your use case. They cannot get your private information from they cannot get your private key from your public key. Let's look at a scenario here. Maybe will help solidify this concept a bit better. So we have these two people, Jack and Jill. Jill wants to send a message to Jack without anyone being able to see it other than Jack. She uses a program called Cleopatra to create a public and private key pair with OpenPGP. And Jack does the same thing on his computer. Jack and Jill exchange their public keys, which again, we're allowed to share with each other, but they keep their private keys to themselves. So Jack has Jill's public key and vice versa, and then they both have their private keys saved on their own computers. Jill writes a letter to Jack. She signs it with her private key and encrypts it with Jack's public key. So she has Jack's public key. She uses that to encrypt the message. Once that message is encrypted, now the only way to go back is with Jack's private key, which Jack has. Of course, she could copy her original message somewhere else, and then that wouldn't be encrypted. But the version that she did encrypt, once that's out, only Jack can decrypt it now because he's the only one with that private key. She sends the encrypted message to Jack via email, and he decrypts it with his private key. All right, so now hopefully you have a bit of a better understanding of the purpose of the different keys. You hold on to your private key, you give other people your public key, they use that public key to encrypt stuff specifically for you, and then you decrypt whatever they sent you that was encrypted with your public key using your private key. For the decryption part. Now let's talk about Cleopatra. So Cleopatra is an application. It's GUI based, so it's fairly easy to use, and it's used to handle all facets of OpenPGP, including the generation and managing of key pairs, encrypting and decrypting messages, digital signatures, and more. Builds exist for Windows and Linux. The GPG for Win package contains Cleopatra and everything you need to get started, so we're going to download that. This tutorial is done using Windows. To my knowledge, there's not a Mac version of Cleopatra, but this does not mean that there are not other open PGP tools. So if you're on Mac, I'll put a link that has some similar software that you could give a try out. Something called GPG tools, and that's basically a Mac variation of the same concept. Now there's plenty of other software too, plugins, extensions that use OpenPGP. We're not going to be talking about those specifically in this guide. The only thing I would say is I would avoid using browser-based PGP websites. So sites that give you like a key in the browser, or they ask for your key in the browser and then they decrypt it. That just generally does not sound like a safe idea, especially if it's not being handled on your computer. If any of that information is being sent back to someone, that defeats the purpose of the PGP. So use standalone desktop apps if possible. And without further ado, let's get into demoing all this stuff. So now we're going to get Cleopatra installed, learn how to create key pairs, encrypt and decrypt messages, and a few other things. Okay, so here I am on my virtual machine. I am going to be going back and forth between my regular desktop and this VM, so we can kind of simulate two different people running two different copies of Cleopatra. But anyways, go to Google or Bing, search for GPG for Win, or click the link that I will hopefully remember to put in the description of this video. And we just want to install this whole package. And I'm poor, so I'm not going to give them any money at this time. I'm sorry, project. Download that guy and just run through the standard install process. And we're just going to leave everything with the default settings. Alright, now I have Cleopatra on my desktop. I can open that guy up or just run it from the installer. Try that again. Okay, here it comes. And since I don't have any certificates to speak of at the moment, it's going to just kind of have this little welcome message here. And we're going to just start by creating our first key pair. So I'm going to give myself a new key pair. I'm just going to call myself on this one, I don't know, John Doe, and my email address, johndoe@gmail.com. Now this is optional. You can protect your secret key with a passphrase, and as it says in the tooltip here, it is unrecoverable. So if you do want to have a password attached to your private key, you will need to remember that password every time you want to sign or decrypt a message. I'm going to leave that off for now. And if you take a look in the advanced settings, you can see like what the key's made out of, different hash methods, and what we're using it for. This is all fine on defaults most likely, but I do want to point out this valid until. So keys have expiration dates, at which point you're supposed to create a new key. I do believe you can still continue decrypting things with the key after that date, but I normally just like to set that to some point a little farther out. Of course, if you only plan on using this key for a limited window, like you're dealing with very sensitive information, maybe you would want to set that to be a shorter time. And just hit OK, and it generated the key for us. Now each key has a fingerprint, so you can see at a quick glance, you can verify that this is the key you're looking for. It's not 100% foolproof, but it's pretty close, as the chances of multiple keys having the same ID are very low, but that is not the full key by any means. In fact, if we want to take a look at what the actual key looks like, let's go ahead and look at the public key and the private key. So remember, the public key is the one we want to be able to share with other people. And if you just go to right-click on the key, click Details, and go to Export down here, this Export option, that'll bring up a window with your full public key. And again, this is the key. It can be used to sign and encrypt certain things. This is the key that we are able to share with other people so that they can encrypt messages to us. So if John Doe wants to receive a message from someone else, he would copy paste this and or in some manner give it to the person that they want to receive encrypted communication from. The private key, and that can be found by backing up the private key. So if we just go to desktop, save our secret key, and remember, you want to make sure only you keep your secret key. If you do back it up somewhere that is very safe, maybe to a flash drive that you store in a vault or something like that, or at least make a copy of it somewhere. If you had a passphrase, you're a little better off, I suppose. It's not entirely unsafe to upload these to cloud service providers. That's generally encrypted anyway, so that's probably safe, but of course the safest way to keep these keys safe would probably be to store it off the cloud on your local machine that is properly protected with a physical backup somewhere safe. Okay, and these key files are actually just basically text document. So if we open this with Notepad, we should be able to see the full key. And here it is. So this is my private key block. And of course, this is the key that I would not want to share with anyone. Of course, I'm sharing it with you guys because I don't intend on actually using this key for anything serious other than this demonstration. So there's my private key. Like I said before, it's just this random string of numbers, letters, and characters. And this part where it says begin and end, there's kind of like comments descending where the key starts and ends. And for the next instruction, I want to take a look at Notepad. What we're going to do now is encrypt a secret message just to ourselves. So go to the Notepad tab, and here you see we have a Notepad, pretty self-explanatory. So hello, this is a message only I can read, right? And then under the Recipients tab, we can sign it as John Doe, and we can encrypt it for me. Now, if we had other people's public keys, we could encrypt it for them as well, but since right now I only have my own private key, or my own public key, I'm only going to encrypt this for myself. There is an option to encrypt it with a password instead of your key. This is not quite as secure as using the key method that PGP is based around. So I would recommend always using your key pair if you can. Anyways, let's go ahead and sign and encrypt that and take a look at what this looks like. So my message, I'll say, oh wait, what? Oh, I don't want to encrypt any files, my bad. So actually what I want to do here is just sign encrypt Notepad. And here is the encrypted message. And I can open a new text document, my message.txt, and save that. And now, if I want to, I can, well, first, that original message is gone, as you can see. But if I want to decrypt that, since I have my own private key already stored as a certificate, it's my key, generated that message using my public key. I can copy that, go back to Notepad, and decrypt it. All right, so we can see here it says it's a valid signature by John Doe, so that confirms that it was actually, sent by me. And here's that decrypted message. Basically, now I can store this anywhere. I can post it in a public forum. I could post it on Reddit, and no one would know what it says except for me with my private key. So that's how you encrypt a message to yourself. If you're going to use it for like journal purposes like that, you would probably be better off giving your key a passphrase. And there is actually an option to change passphrase, which you can do. So if I just do this, let's see what it looks like when we use a passphrase. And for testing purposes, I just went with something really simple. But you should always use standard security practices when creating your passphrase, at least 8 characters long, symbols, letters, numbers, that kind of thing. I'm going to stick with my insecure passphrase. And we're still going to take it. Okay, passphrase changed. Now let's see what happens when I go ahead and, clear this out. So now if I try to decrypt this, it's going to ask me for the passphrase on the secret key. So basically my secret key's been updated. It's still similar to the old one, but that passphrase has been added to it. If we looked at the public or the private key file itself, it would actually be slightly longer than the first one we looked at. But now I can encrypt and decrypt messages with my private key. So if you're on a computer that is shared, or you want to keep a secret journal, you don't want your significant other to see it, something like that, you could do it this way using that passkey or password, basically. And on to our next demonstration. So now we are going to look at sending an encrypted message to someone else. Recall that to send an encrypted message to someone, we're going to need their public key. In this example, I'm going to be on my other computer under my name of Kevin Olson. If we look at Cleopatra running on my computer, I have a certificate for myself with my name and email address, and I'm going to be writing a message to John Doe that I only want John Doe to be able to see. Now, if we go back to John Doe's account, first I'd have to contact John Doe and say, hey, I want to send you an encrypted message. Can I please get your public key? Then John says, sure. They go to Cleopatra and they export their key to me. There's a couple ways you can export it, but if you just select the key pair or certificate you want and click the export button, it will generate a file that we could give to me, to Kevin. So John would give this public key file, ends in public there, so we know that's the right one. They would give that to me. And again, that is just a text document with a different extension. If we go to look at export here, this is what that key file contains. So let's look at doing this a couple ways first. So say you're on the internet and you get this, like I could just send that as an unencrypted email if I wanted to, back to Kevin from John. Then I go to my computer. And once in my computer, I open up a text document, and this is John Doe's public key, and I just save it as a .asc file. So instead of .txt, I just write John's key.asc, and now that's a key file instead of a text file. I can go ahead and import John's key now. And when we import keys, we're supposed to certify them. So if you know the person and you trust the key, then you can pretty much just certify it right away. And certify, certify, certify. All done. Easy enough. So now John's key is certified. I have his public key stored in Cleopatra on my computer. And now, me, Kevin, now I can use that to write a message to John Doe. So I could say, hey, John, I know this is inappropriate for the workplace, but I have a huge crush on you. Will you go out with me this Thursday? Sincerely, Kevin. Okay. And my recipients sign as me, so he knows it's from me. Encrypt for me, that's fine. You can encrypt it for yourself if you want to, in case you want to be able to decrypt the message later. If you want to be super secure and only John reads it, then you might just want to encrypt it for John. You type John's name or his email that's associated with that certificate into there, and now I am signing it as Kevin, encrypting it for John Doe. So I go back to Notepad, I sign encrypt that, and it has been successfully encrypted. Now I can go to Gmail or whatever, copy that, paste that in, and John receives it. We return to John's computer now. John gets this email, and let's go to Notepad, and let's close that, and let's decrypt this. So it's going to say that it could not be verified because I don't have Kevin's key on John's computer. I don't have Kevin's public key. You need the public key of someone to be able to verify that signature. But you can still read the message if it was made out to you using your own public key. So even though I don't have Kevin's key, I can still read the message. Anyways, I see, hey John, same message. I have a crush on you. Will you go out with me? From Kevin. And then if I have Kevin's public key, I could just do the same thing in reverse. So Kevin exports his public key, and John imports it into his version of Cleopatra, And now John can write a message back to Kevin the same way Kevin wrote a message to John, and they could both verify the recipients with each other's signatures. So that is how you send and receive encrypted messages to other people and sign them. And signing is optional. I would recommend it if possible, but you don't necessarily need to do it just to send a message to one person. Okay, and the last thing I want to touch on here before we end this is how to encrypt and decrypt files. So suppose you have an image on your computer that is super private, or document, or whatever. You don't want to share it with anyone. So this is my Shiba who secretly likes flying planes, and I don't want anyone to know that he's been flying the planes when I was supposed to fly the planes. So I want to encrypt this so I can look at it later, but no one else can see that my Shiba is flying that plane. So we just right click. If you installed Cleopatra with the GPG or open the PGP tools, whatever that I talked about earlier, there should be an option on the right click menu in Explorer. If you don't have this, if you're using Windows 11 and you haven't changed it so it just automatically goes to the more options, you will have to click show more options, which I hate. But if we go down here, we can see this little lock icon and it says sign and encrypt. We can sign it as John Doe, encrypt it for me, John Doe, and I'm not going to encrypt it for anyone else because only I want to be able to see this. And maybe I will change that name of the file to something a little more hidden. So super secret picture.jpeg.gpg. And I just do sign and encrypt. Now signing and encrypting succeeded, hooray. And now we see we have super secret picture.jpg. I can delete the old one, or .jpeg.gpg. And if we look at the properties here, it's still 151 kilobytes, so definitely not just a small text document. You could even remove that extension if you don't want people to know what file type it is. But anyways, let's go ahead and open this with Cleopatra. And it's just going to automatically decrypt it since I have the private key for myself on this computer already. Save as the original, dogplane.jpg. And now I can look at that photo of my Shiba driving the plane again. Okay, that concludes this tutorial on PGP and Cleopatra. If you'd like to see more videos like this on tech-related subjects, I also do programming and web design videos. Feel free to subscribe, like, comment, and if you really appreciated this video, go to my website, kevinsguides.com, and leave me a tip of any amount. Thank you so much, and take care. Bye.